Hello, everybody, and welcome to Color Space Cadets, where we are joined by Bram Desmet from Flanders Scientific and Joey and Robbie, who have both used the brand new reference monitor from Flanders, which actually breaks some serious headway into a new way of monitoring and a new way of thinking about reference monitors. So we'll get to that. Let's start off with some introductions. Bram, would you like to just introduce yourself, please?
Yeah, I'm Bram Desmet, Flanders Scientific CEO, and I'm really happy to be here. Thanks for having us.
Cool. I'm Robbie Carman, colorist at DC Color. Been a colorist for 25 years. Yeah, that's me.
Yeah, I'm Joey D'Anna, also colorist with DC Color, partnered with Robbie here in the kind of Washington, D.C. area. Yeah.
Okay, so let's introduce this session. So the future of the session is the future of displays. And before we get to that, let's just kind of recap on why we're having this discussion. Over the last 12 months, there have been a number of display technologies that have come and gone, basically. I think, Bram, you're probably the expert on this, out of the four of us at least. The ones that have disappeared, first of all, we've seen the Japanese OLEDs disappear.
Yep.
And tell us a bit about what happened and how that affects people like Flanders Scientific.
Yeah, so it was something that had been rumored for quite a while that might happen. So it it didn't come as a massive surprise that it happened. The timing was a little surprising because there was almost no warning. It was just one day, hey, we're out of business and we're not shipping any more panels and things are done. Production line is shut down. Very different from, say, like the kind of spool down of the RGB OLEDs from Sony's semiconductor division back in the day. So it was a kind of abrupt end to that technology. Very promising technology in terms of overall performance. But there are a lot of things that made it difficult to do business. One being that it was something that's really ended up being kind of a product for niche markets, like really high-end computer displays. And then for the professional market, of course, as well, there are a few people using it for professional monitors. But one of the things that was difficult for that technology was that it simply wasn't very bright. So you might get 500-700 nits or so, but really not good enough to be like HDR mastering level. And that also kind of reduced the potential scope of those displays in terms of where they could be used. So it's always a tough market. And that's, one of the reasons that we're really excited about technologies that have broader scope, things that can work well in a lot of different markets, including consumer TV market.
So, and the thing about these Japanese OLEDs is that because they were RGB, they calibrated better than the white OLEDs that are used in televisions, but they were still representative in terms of dynamic range. And we've also seen the dual layer technology of the ISO and the Sony HX310, and indeed I think at one point Flanders had, was it the 312 or the
311?
311.
311 had LMCL panels. And LMCL was a great technology that I think that served a purpose for a bit in terms of giving us very, very high contrast and being able to get to close to 1,000 nits. There are several limitations with that technology that make it commercially, very difficult. And that is that they generate a lot of heat, they draw a lot of power. So in terms of making like consumer television versions of it, it's difficult to even legally sell it in some markets. Because of things like power consumption. And the other thing is that trying to push those boundaries, getting to like 1,000 nits, a lot of these displays are 1,000 nits on paper, but when you measure them, they may come up 50 nits, 100 nits, 150 nits short. And then the real important thing is what happens 2-3 years down the road as these start to dim over time. They're not consistently getting back up to 1,000 nits. Now, they were important because there were not a lot of emissive technologies like OLEDs that could get bright enough, of course. So if you wanted a 1,000 nit option, this was one of the few ways to really do it well. So I think they served a purpose. I think in terms of long-term viability, I think that technology probably won't be, it was kind of a stopgap solution. It probably won't be with us too long-term, especially because it has other kind of knock-on side effects or limitations, like off-axis viewing tends to be quite limited on those. There's a lot of color shift because you're dealing with a fair amount of panel stack you have to get the light through. So
yeah, I think for me, that's the important point, is that technology was popular in the grading and the finishing suites because it does meet the reference standard of 1000 nits, full screen, but it was never going to be seen in consumer devices. So that whole point about having something that is close to a consumer device doesn't exist. And as you said, that technology is short term. So Sony have now pretty much acknowledged, I think, that panel is no longer available. They've come out with another dual layer panel, the the HX3110, which is up to 4000 nits on 20% of the screen, 1000 nits full screen. And that's not released yet, but from the prototypes that I've seen, that looks interesting. Not so much because it's 4000 nits, because I don't think there's a huge demand for that, but they have actually listened to some user feedback and redesigned their menus. And it's got some nice conversion stuff in there as well. So that does look like a good replacement for them, but it's never going to reflect what's in the home. Let's go. Sorry, go ahead.
I was going to say, so like one of the things that we're really keen on too is that we've had all these technologies like LMCL and various full array local dimming options, and the fundamental issue with a lot of that stuff is it's kind of science experiment type stuff where it exists maybe well in our ecosystem, but it's hard to be long-term viable. The problem is, of course, these factories that make panels, these are 500 million for a tiny one, up to the several billions of dollars to make these panel fabs. And if you can't find those large markets, you have this cycle of these technologies that come to market and then go away because it's not a good business model for people to be in. What we love about some of the new technologies, like the QD-OLED, for example, that's in the XMP 550, there's this huge consumer analog for it, right? So they're selling these same panel technologies. They can sell hundreds of thousands of them, millions of them into these other markets. So it's something that we feel has a lot more staying power, and it will also be kind of the top end technology on the consumer side. And we love that there's going to be this consistency now, hopefully, between the pro world and the consumer world, things mastered on a certain technology, seen on a certain technology at home, and something that we can rely on being around for many, many, many years to come.
Okay, let's bring Robbie and Joey in. Robbie, you run your own colorist shop there. Yep. Give us a little bit of a history on how you have chosen reference displays over, say, the last 4 or 5 years.
Yeah, so those who know me know that, and Bram will have a giggle at this because I'm constantly calling him, asking him questions and calibration stuff and all that kind of jazz. I like to be a little bit on the bleeding edge of this stuff, whether that's to my own fault or not. But early on, I was I jumped on OLED bandwagon like everybody else because it was just such a visually impressive kind of thing. And then that certainly played true with the WRGB OLEDs. I was an early adopter of those LG panels, because I just thought from a client experience they were great. And then later, for SDR only viewing, you can calibrate them to be essentially perfect even on a consumer panel. But one time Bram's company was selling like a professional version of those, got into those and been using those as client monitors, but also at home. I've been using the 55 version of one of those WOLEDs from FSI for a while now, and they served me well. But when we started getting into HDR stuff, it was unfortunately the very kind of the X300 had come and kind of gone, and now everybody was looking for what's next. And at that time, I had the choice of LMCL or Phalid, and I got to be honest with you, I was kind of lured by 3,000 nits, 4,000 nits. And that's the direction that we went. And we have a couple of the FSI 310Ks, which is a 3,000 nit Phalid display. And, I'll be honest with you, I love the display. It gets obviously super bright, but I would be the first to admit it's not for everybody, right? There are, I always like to give, Joey and I like to give the analogy of like driving a manual car versus an automatic car. And those phallic displays are often like driving a car with stick, because you're changing things like modulation modes and all that kind of stuff to suit what you're doing, small points of light or motion or whatever. And over time you got to get used to it, but still in the back of my head, that's kind of like, man, I'm constantly pushing buttons on this monitor to get it to do the right thing. And then there was other issues with those kind of displays, like like just honestly in a static mode having lifted blacks, and then the kind of that, all that kind of stuff. So anyway, it's been a journey, and I've played like everybody else. I've been experimenting the JOLED panels. I got one of the LG EP950s to try out and was really impressed with that, but at the same time it didn't really get all that bright. And so when Bram said, hey, look, we're thinking about doing this QD-OLED thing, I was very excited to lay eyes on it and give it a try. And Joey and I were lucky enough the past 2 days, Monday and Tuesday of this week, actually, to dive into it and really grade a whole project on it. Not just like sit in front of it for 5 minutes and kind of like look at it and get an impression, but moving the dials around and see what happens and where it falls down and where it doesn't. And I walked away personally going, yeah, this is going to be, this technology, I think, has a little bit more of staying power over the next, 3, 4, 5 years than some of these other things that did. Now, that kind of hurts a little bit because I invested a lot of money in, phallic and all these other kind of things. But at the same time, the 50,000 foot view is that this QD-OLED stuff to me represents kind of a set it and forget it kind of thing with a panel. Can tangent, go between SDR and HDR easily. It's hitting over in the bigger size panels. It's hitting, close to 2000 nits, which is, good for a lot of people. And then it has all the benefits of OLED, black level, super wide color gamut, that kind of stuff. So I think it's pretty exciting.
Okay, there's a couple of questions that have come in. I'll come back to you in a minute, Joey, because I have a great question for you too. But just to answer some of the questions that are coming in on YouTube, the first one, which I think everybody would like to know, is will there be a 42-inch version? Not a 32, a 42-inch version.
Yeah, so what I can tell you there is that the technology generally is very scalable, right? So it can definitely get smaller, and it can also get larger. There's nothing specific. I think it's safe to say that there's nothing specific kind of at that 42-inch size. But there is definitely smaller than 55 that is, at least on a technical level, certainly possible. The main limitation as you go smaller on these is really the resolution at which you can print because the quantum dot materials are printed into place, inkjet printed essentially. And really the limitation is at what PPI, what resolution you can do that at. So we're now at PPI on quantum dot OLED technology that's allowing to say down to maybe like a 32-inch panel. So smaller is possible, but there's definitely, if you look at just general market demand, because again, a panel supplier is going to be drawn to building panels that they can sell a lot of, right? And in terms of market demand, there's demand for 55, there's demand for 31. That kind of 40-inch range is for the rest of the world outside of the color correction kind of market.
Cool.
Is kind of a dead area. There's not a lot of motivation to build something right that size. But over time, as these lines mature, they start trying to fill in these kind of more niche gaps because they can, and it presents new opportunities. And so you see those sizes tend to come later. And you saw that, for example, with WOLEDs, right? So with WOLEDs, it was 55, 65, 77. And then they were like, all right, well, now we're going to make like a 48 and maybe we'll make a 42. And so those things tend to come later. So I think it on a technical level is very possible. It's really going to come down to whether it's commercially viable for the panel suppliers to do it.
So is a 31-inch panel manufactured at the moment? Is that something you could take on board?
It is very scalable technology. I definitely would keep your eyes open.
Okay.
There's what I can say now is that on QD-OLED panels at the moment, there's nothing currently in mass production that is both UHD and smaller than 55, but
Okay.
that is very likely to change.
Okay, good to know. Joey, let's bring you in. Sorry to keep you waiting so long. I was going to ask you about TV setups in the home, but before we get to that, another question that's come in on YouTube is about this idea of 4000 nit mastering. So obviously Dolby had a 4000 nit standard. Ivan Anthony is saying that he's hearing a lot of streamers asking for 4000 nit monitors as soon as that's available. You think that's something that's going to take off?
Currently, I don't think requiring grades up to 4000 nits is going to take off, no matter where the monitor landscape goes, just because there's a lot of creative implications to that. Where do you want to get that bright? How often do you want to get that bright? But having higher nit level monitors available, they're accurate in brighter areas with brighter, better color volume, I think is really important for basically any HDR grade. And the reason is, let's go back a little bit to some of these earlier technologies we were talking about. I've always said for many years, when people ask, oh, what monitor should I buy? What should I look at? You know, what's the landscape looking like? My general answer has been, well, there is no perfect check all the boxes HDR display technology, right? If you want bright, you're going to deal with the full array local dimming stuff, and you need to understand that, right? If you want perfect contrast and 1000 nits, you could use the LMCLs, but then you get honestly really, really, really bad off-axis viewing. And I, like Bram mentioned, I had very big concerns about longevity of those displays because of all the power usage and the heat that you don't get in other technologies. So there's always never been like, oh, here's a display that ticks all the boxes. After having sat with it for 2 days, the QD-OLED really ticks all the boxes. It's as close to a no compromises mastering display for HDR as I've ever seen at any price point. It's really impressive. So to talk about those higher nit levels, for example, the 550 that we're talking about, it's around 2000 nit peak, right? To me, that is giving you all the headroom in the world to make perfect 1000 nit grades, right? Because you know that even as the display ages, all technology will age, and any display will probably get a little bit dimmer over time and need to be recalibrated. Having that headroom, they know that you're hitting higher than you need, is massively good. And that's one of the reasons why I went with the 310K. Most of my HDR grades, I actually went through when we were evaluating the 550, some old projects that I had graded on the 310 and kind of looked at where my absolute peaks were. Most of them were like 1500, 1600, etc. So if I was on an LMCL panel, those would have been clipped, right? If I was on a WOLED, those would have been clipped and I would have had color volume problems. But if I'm on a 2000 nit panel, I know 100% that 1000 nit grade, I've got more than enough headroom to wiggle around that area. So I don't think if we had a 4000 nit capable panel right now that I would start wanting to do grades up to 4000 nits, because I would want something with a little bit more headroom than the 4000 nits and kind of stay in the sweet spot below that.
Can I add something to that?
Yeah, that's the kind of the long short answer is a lot of streamers are asking for 4000 nit mastering target grades. Do they really want you to hit 4000 nits? I feel like that's more of a creative distinction, but having headroom, I think, is an important thing.
I don't think that's what they're asking for. I think you're right. They're asking for a 4000 nit archival master essentially, but that doesn't mean that artistically that you have to hit 4000 nits.
And I'll tell you what, there's a big difference between a specular highlight at like 900 nits, where you'd be underneath that 1000 nit cutoff if that's all your monitor can do, and say 1500, 1600 nits that something like the 550 or the full array local dimming displays could easily hit. You know, yeah, I'm not pushing to 3000 or 4000, but I'm going a little bit above 1000.
Yeah, I would add to that two things, Joey. I think that one, again, going back to, you know, as I admitted to, one of the reasons we were seduced by, you know, high nit phallic displays was because I think there was a thinking at that time that we were going to move, because of, you know, what PQ was, you know, able to do up to 10,000 nits, you know, on a theoretical level. I think there was a thinking that we were going to not just talk about speculars and peaks, but this idea of kind of shifting the bar of average APL significantly up over time because these displays could do that bright. And I think in reality, you know, I've said many times that the vocabulary of HDR has been changing over the years. And I think if you do a pretty good analysis of popular content that's out there these days, that language has pretty much landed on, no, we're going to keep the bulk of our grade between, you know, 100, maybe 150 nits or so. And every once in a while, we're going to sprinkle some wow factor on top of this for, you know, things that work for it. You know, I'm thinking of control panels.
Yeah, if the whole grade is 800 nits, it's not HDR. It's just
right.
bright.
Right, exactly. And so I think that's part of the challenge here too. And I at first I thought it was almost like acquiescing, like, oh, fine, we're just not going to do it because the technology doesn't exist. And the reality of it, and I'm guilty of this, you know, I try to often in my first stab on things push it way high. But I think the reality of it is that, you know, even though companies might want a 4,000 nit master, they're not saying. I think this is an important distinction. They are not saying that we want an entire grade that exists way up here the entire time, because that's not only going to work. That's not going to work for everybody, right? That's not going to work. It's not translatable through Dolby Vision mastering, etc. I think they're saying what you guys are saying. Hey, we want a 4,000 nit container that we can check that box and put it in archive and be good with it.
And it's really important to remember that there is a 2000 nit Dolby Vision mastering target. So It hasn't really been used a lot because there haven't been 2000 nit monitors on the market, but that does exist. And there is a 2000 nit ACES output ODT if you're working in ACES. So it's not like this is unheard of in terms of the mastering level.
Yeah, and Bram might be able to speak more to this, but my understanding through researching quantum dot OLED is that, you know, the biggest limitation of getting even brighter is going to be heat dispensation, right? So, like, you know, as this technology continues to grow and exist, I wouldn't be surprised if the manufacturers, you know, panel manufacturers and stuff, figure out better ways to dissipate heat, therefore, you know, able to creep that number up over time. You know, depending on how that manufacturing works.
Yeah, you're correct in that dissipating heat is definitely one of the main kind of limiting factors. The other thing, though, is just the efficiency of the materials, and you know, not to artificially get anybody's hopes up, but for the long term, you have to remember that these materials do keep improving. So the jump from Gen 1 to Gen 2. Largely due to efficiency gains and the way the panel is manufactured, is that we went from 1,500 to 2,000 nits. And so I don't think you're going to see a huge jump in QD-OLED peak luminance in the next, say, 2 to 3 years, but maybe 4 or 5 years from now. There's a lot of things happening in terms of quantum dot manufacturing that is giving us a lot of hope that things are going to get brighter over time, without necessarily having a huge impact on the amount of power draw or heat that would be generated. So it's a technology that will evolve further in the years to come. And this is a big change for me because I had to get my head wrapped around this, because for the longest time I was like, oh, OLED, because of HDR, just may not be the technology. And we saw that for a while where it just couldn't get bright enough. But these QD-OLEDs obviously have shown that can change. WOLEDs even showed that this could change a little bit because we were getting brighter and brighter, but now we're doing brighter and brighter without.
Okay, so I think we pretty much all agree on the brightness that from a colorist point of view, having more brightness is better for grading. And that really the benefit of going anything over 1,000 nits is that instead of pushing your spectral highlights into clip, you actually get to choose whether you want them to be at 1,500 or 2,000 or whatever. So it's more accurate from that point. What I want to do is come back now to sort of one of the more controversial areas about the size of the screen. Because, for example, in my office and my work suite, I don't think I can put a 55-inch display without really rebuilding the room. I can't get it on the desk, and my suite at Mission is a projection suite, and that's going to be difficult for me to put that in there. And I totally get, you know, that quantum dot OLEDs meet a requirement that has totally been missing in the market. How much of an issue do you think that is? Let's start with you, Bram. That must have been a big consideration when you adopted the technology.
Well, so the thing that I like is that I think QD-OLED is good enough to be used as the primary reference display. So, and we have for a very long time had so many people asking for something that is larger and good enough to be used as the single monitor in a suite. I think this is going to work for a lot of those rooms and a lot of those customers who have been asking for something like that. Now, we have no illusions, though, about everybody just switching to single monitor suites, or that 55 is the perfect size for everybody. So again, the technology is very scalable, and we agree there's going to be setups where you need a smaller monitor and a larger monitor. The 55, I think, will work as a single monitor for a lot of those rooms, though. And of course, there's no harm in if you do decide to use it just as a client monitor, and having your client monitor be as good or better than your mastering monitor. So we think it's going to tick a lot of boxes for people still. But Joey and Robbie used one this week. They sat the distance they were comfortable sitting from the monitor, and they probably have some good feedback on their general feeling on that.
Yeah,
sure. I mean, can you give us an idea of how far away from the monitor you sit?
I'll give you better than an idea. We measured it.
We measured it.
We measured it to be about 60 inches was my preference. Robbie's preference was probably about 50 inches, about a foot less than mine. He wanted it a little bit closer. And it was interesting because the second I got home, it's still sitting on my desk, I got out my little tape measure and measured my preferred distance to my 31 inch. And I found it to be about 31 inches. And I liked about 55 to 60 inches on the 55. So in my preference is about an inch away per inch diagonal. That's not based in any kind of scientific research. It's just where I feel I can see the entirety of the monitor without having to move my eye, because that's the big thing to me. If I'm watching something down, I want to be able to spot a dead pixel in the corner or a QC issue that's going to be a problem somewhere in the field of view without having to move my eye. I will say this about the new QD-OLED displays. The off-axis viewing is far and away the best that's ever been put on a display since CRT days.
I agree with that.
And I don't mean like, oh, it's a little bit better. I mean, it's astonishingly better.
We should have taken a video of us walking around this display, because we were so
up, like down, left, right, 45, 50 degrees out, still like reference level accuracy.
No color shift, no luminance shift. It was pretty impressive.
Which means for the room layout concern, if you are trying to go to a single monitor, it gives you more options, because before, if you had even a WOLED, those had viewing angle issues where I wouldn't want it to be the single monitor in a suite unless I wanted the client to like literally sit in my lap, right? And that's the other thing too, on a big display like this, you need good viewing angle, because if you just move around a little bit, you know, the geometry of it is going to mean you're getting into some viewing angle issues if it can't handle off-axis viewing. I love my 31 inch. That's my favorite size. But like you said, if you wanted to move to a 55, you might have to rearrange the room and think about it a little bit. But
I'm a little biased with this, Kevin, because I have in my home suite here, not at the office, but in my home suite, I've been using a 55 WRGB OLED as my main SDR reference for a long time, and I sit pretty close to it. I sit probably about 3.5, 4 feet to it, so I'm used to that feel. I think that going to the XMP 550 this week, it just felt normal to me, like at that size. I can see if you've never worked on something that big, that close, it's going to take a little bit of period. But even then, I think it's pretty fast adjustment. And the reason I think that is because of 2 or 3 main reasons. Number one, the viewing angle thing that Joey said. One of the problems I've always had with the WRGB OLED being close is that I'm kind of doing a little bit of this and left, you know, checking saturation, kind of shifts, color shifts, depending where I am. The other thing that, and I you have to see it in person, because it's really hard to describe in regular language. And the past couple of days, we went back and forth about how to actually say this. The reflectance of the screen is a huge, gigantic change over anything I've seen before. It literally looks like a black hole of, you know, this thing just hanging out in space and sucking all light into it like an event horizon.
Yeah, I mean, And it's not just that it's a matte screen, because it's not a completely matte screen. My XM310K is a matte screen. I can still, if I shine a light at it, I can kind of see it. If you shine a light on a XMP QD-OLED display, yeah, you'll see like a little bit of reflectance, but the amount of ambient room stuff reflected in the display in the blacks is dramatically lower.
Yeah.
I mean,
for that reason, I feel like you can actually sit closer to it, because you're not having to manage a lot of this reflectance, kind of shift kind of thing, depending on where you are on the screen. But again, like that kind of thing is always going to come down to a personal preference. I would say one last thing about it is that 55, especially in the case, the actual physical case that Bram and the team has designed for this, it really doesn't feel that big, right? Like, it feels like a more svelte kind of compact monitor than it actually is. Even compared, I'm looking at a WRG OLED right now, that just feels bigger and kind of flimsier, to be honest with you, the way the case works. Bram and his team have done a really good job designing that case on this display. So yeah, I mean, I think it's going to be a preference thing, but I think we could sum that up by saying, 3.5 to 5 feet is probably, a good working distance. But that's going to be subjective based on who's working on it. But it's definitely doable.
Yeah, and one last thing to say about it, it would be an adjustment because we're not used to it. We moved from 25-inch, RGB OLEDs and LCDs to 31-inch,
and those felt
really
huge.
happily.
Yeah, those
really. Yeah, initially it felt huge. Like I said, I love my 31-inch. It's still my favorite size, and this distance is my favorite distance. 5 minutes in working onto the 55, because it was at what I felt was the right distance, like nothing. I mean, it was not like a huge adjustment. It's just like, oh yeah, this is big, cool. But we just went back to grading.
And you have it wall mounted then, I'm guessing, right?
It was on a table.
It was on a table.
So this was on a table. So we have we basically just scooted our desk forward, a couple inches, and then we put another table behind it, a thin table, and put the monitor there. It could very well be wall mounted. We didn't, because this is the one in Atlanta is the only one in North America, and we just don't want to.
Okay, and I did
it's
have
not particularly heavy.
No, people are asking where they can
super
see
light.
this monitor. How many prototypes are there of that monitor right now, or how many of them exist?
There are only 2 right now, but it's about to change in a big way. Our panels actually just left the panel manufacturing plant this week, so we're going to be starting on mass production assembly on these pretty darn soon. So that'll change. We'll show it at IBC, so you'll be able to see it there. If anybody is in a super big rush to see one like now, we are doing by appointment demonstrations in our Atlanta office. You just reach out to our sales team and they can set up an appointment in our grading suite where Robbie and Joey were working. We have a full resolve system there, so you can kind of put it through its paces there. But it will be at IBC is the next big trade show that we'll have it at. Actually, in BIR TV, if anybody's going to Beijing, we'll have the unit there as well. And then shortly after IBC is basically when we expect this kind of first flood of mass-produced versions to come in. And that's when we'll start, really hitting the road in terms of key markets. Will be in New York, we'll be in LA, we'll be in London, we'll be throughout Europe with the unit. So it will.
We have a question about New York.
Half of this year, you'll go ahead.
Fourth quarter for New York.
I think. It will definitely be at NAB New York. We'll be at that trade show, and then we will probably even before that. We'll be hitting. We'll be trying to set up demo events in different areas with different partners. But reach out to us, get on our demo list. We will be visiting clients with the monitor, but we'll also be trying to host events in key markets so that if several people want to come to the same event and see and test the unit, you'll be able to do that. But yeah, second half of this year, we're going to be extremely busy. Our sales team's getting prepped on these, and we'll be trying to, get out and see as many people as possible so they can take a look at the unit.
Cool. And the black level is super interesting. So let's talk a little bit about, we've kind of grown to accept that CRTs look different from plasmas, and plasmas look different from LCDs, and LCDs look different from OLEDs. Can you sum up what your thoughts about the look of a QD OLED is and how influential that's going to be going forwards?
So I think we have to start with the reflectance. I think is important. So it is very, very low reflectance. So they could do this like amazing contrast level. The black level is 0.0005. So you get, in theoretically, you get a 4 million to 1 contrast. So that will depend on the room setup, of course, a little bit, and how much ambient light there is. But it's very high contrast. In terms of spectral distribution, I find that the spectral distribution is really helpful in making this look like a lot of standard technologies. So when you pair it with a 310K or you pair it with, an iPhone screen or whatever, I feel like it just translates well. I think the vast majority of users will not want to use an alternate white point or alternate color matching function. We will support that if you want to. There's a lot of customization. You can do these things, but we think most people will be perfectly happy with it. Just plain vanilla D65 setup, it'll work just fine. And then so to me, I think that it's a technology that just feels right. Also, things like skin tones don't look odd like they do on some other technologies. They always feel like, even with alternate white points like WOLEDs, like there's just certain things that look a little different than they do in other places. RGB OLEDs, like the old Sony panels, they just looked different than most other technologies. So I've been really surprised that I've been doing display for a long time. You guys can't tell, I've been more excited about QD-OLED than anything since I've started in this industry. It's really
Kevin. I would add too, from like a so this is, I think, the widest gamut display I've ever looked at in its native gamut. And when we were working on it, it was funny because in prepping the project that we were going to grade down there, we were talking to Bram, like, oh, should we do this P3 D65 limited in a 2020 container? Like, how do you want us to work? And we went straight for a 2020 like straight workflow on it. And it's pretty unbelievable when you really crank that. I don't know, Bram, I think the number is like 90 or 92% or something like that of 2020 that it does. And
yeah, it's over 90%. It's about 91% or so of Rec 2020. Yeah.
But in practicality, from like what you would, as far as you'd probably go as a normal, even-minded colorist, it's unbelievably outstanding. I felt like where I feel like I had seen levels of saturation and depth that I had never seen, especially in deep blues. I was just astounded by the deep blues. Like I've never seen that color on an emissive display at all. I mean, it just had that depth to it. We looked at some stuff that was obviously over cranked in reds and stuff, and some of that was just, it's phenomenal. Probably wouldn't go that far, in a normal grade.
In an actual grade, yeah.
Yeah. But the one other thing that I think that is worth noting that I think was a big, huge like gotcha for me, or a surprise, was because, again, coming from a phalid display where there's compromises in terms of how those zones work and the fall off around those zones and points of light and stuff like that. We looked at some sample footage of some like car headlights where, looking at it on a phalid display, you kind of got this like blob of light, right? Because it kind of couldn't figure out which particular zone was supposed to be in control of that or whatever. And then we looked at this on the QD-OLED, and you're like, oh no, there's two distinct headlights in this.
It's pixel perfect. You can have black next to crazy, and I think it's there.
And I think the people, rightly so. I mean, I've had some of the same complaints, but I've just learned to deal with it. The people that have been driven crazy by the performance of phalid in that particular regard, of small points of light and how motion smoothing and there's blooming and stuff works, I think are going to be really, really shocked. I mean, we looked at several clips that just destroy our 310Ks, like destroy them. And looking at here, we're like, yep, I can see every single one of those dots perfectly clear.
Starfields, the nightmare scenario for any display. Perfect. But the one thing I would mention in terms of black level performance, so I think is really, really important. I've said for a very long time that I was never satisfied with the black performance of the RGB OLEDs of the Sony panels or of the WRGB OLEDs. And by not satisfied, I mean they were clippy, right? They looked amazing, that perfect black. But I feel that when I moved back to an LCD, and some of this might be subjective, but I strongly feel that when I moved back to an LCD, I could see deeper and better detail into the blacks, and I did a better job grading as a result, right? You know, yes, the black levels on the full array local dimming LCD are not perfect zero, but we can't see perfect zero anyway, right? Like our eyes are not going to let us see detail when it's that super dim, especially if you're losing information in that near black like you do on the WOLEDs or even on the top emission Sony OLEDs that we used to all love, right? They were a little clippy coming out of black. There's no getting around it, which is why a lot of people calibrated them, myself included, to elevate the black level artificially slightly so you could see deeper in it. On the QD-OLED, even down to absolute zero black, I basically put in the color generator of a full field and just went up in like 0.5% increments with the keyboard. You could see them from 0 to 0.5%.
Yeah.
You could see
So
it come up.
let me just ask Bram though, is that Flanders Scientific or is that the panel itself? Because I've noticed with other technologies, you go to different manufacturers, and I know exactly what you're talking about, Joey. That sort of coming out of darkness is very often not smooth, but it's different between
and
manufacturers.
it's fine for a consumer viewing it. It looks beautiful. You've got deep blacks, but for reference, you don't want that.
Well,
So,
but
to answer your question, Kevin,
coming out of black, how does that?
Yeah,
Is that Flanders or is that the home TV?
So it's a combination. So I mean, you can still take a QD and set things up to clip if you're not calibrating it well, but the combination of the QD-OLED panel and the calibration that we do on it facilitates this really smooth kind of rise out of black. But that's something that we always struggled with in terms of calibrating RGB OLEDs and WOLEDs, is that they tended to come to us with a native behavior that was rather clippy or jumpy. So you had this like, you could do black really well, but like the question was always, what's the first step you can do above black? The beautiful thing about the QD OLEDs is that we can do measurable kind of jumps out of black smoothly and subtly and accurately that are so small that you might not even see them with your eye. You can just measure them with a probe. So there's a lot of flexibility there in terms of what we can do with the panel because it natively responds so well. So we're getting jumps as little as 0.0005 nits at a time. You can do in a jump, which is just phenomenal kind of subtlety in terms of what you're able to achieve.
Complete practical example of this. The piece we were grading, we had done a first pass of it. Both me and Robbie did first passes of it on our full array local dimming LCDs and our OLEDs. We got there and we found a couple power windows that were visible in the shadows that we had never really noticed before, and we actually adjusted for. So we spotted details in the signal that we never saw on our other displays, and that was.
And to address, that's true. That was very surprising. It makes you feel how many windows you've let through over the years. But the other one was, with WRGB OLEDs, the one thing that's always driven me crazy is kind of like, it almost looks to me like macro blocking coming out of black. It's kind of like this bloom that exists, right? And you kind of get like almost like static and stuff. We did a couple tests where we did like really long dissolves, like 5-10 second dissolves to black and out of black. And I think the only place, like at the really low end, like that first 0.5%, you might say you could see like a little bit of a jump, but from there on out, it was butter. It was perfectly smooth and out. And that was a big deal because we have a client that we work with a lot that's really sensitive to how his fades work. And we've sat in front of a WRGB OLED being like, I don't know, I think it's a signal. And he's like, I think it's a TV, and gone back and forth on that. And this just proved that it was a limitation of that technology at the time. So no, in that regard, it's really good.
Okay, so we've got good star fields, we've got good contrast, we've got good blacks. This is all sounding good. Something that came up on the internet a little while back was the fact that the pixel pattern, the RGB patterning behind it is different. Does that cause it to look any different in terms of sharpness, resolution? Chromatic aberration was raised at one point.
You have to be sitting really, really, really close to even notice it, to the different pattern. And I think the one really important consideration with this too is that you have to remember that even WOLEDs, which we've been using as client monitors forever, people have been using it as SDR mastering monitors. They also have kind of an unusual subpixel structure, right? It's 4 subpixels. So you don't get kind of that perfect RGB stripe kind of arrangement there anyway. And also the types of things that people are noting have been more when it comes to trying to use it as like a GUI monitor or something like that, and looking specifically at text. And the other thing we have to remember is that this text has been kind of designed in all these OS systems to be optimized for this RGB stripe pattern because it's what's common. So you can even do things with like playing with fonts over time that may be able to optimize if you were to use this technology as just a GUI monitor. But from any normal sort of viewing distance, I really don't think it's a real world concern. If you get close enough and you take a picture with your iPhone, you can definitely see a difference in the pixel structure between this and an RGB OLED and a WRGB OLED. So yeah, you can. It's real. There is a real difference, but I don't think it's distracting.
Yeah, and specifically,
and
Kevin,
anything...
sorry, Joey. I was gonna say, Kevin, if you're specifically, because I had gotten early on just to see what it was like. I got in one of the Dell gaming monitors, the QD-OLEDs, like the first gen that they had come out with, and that was a big deal on that monitor. I could, like, anytime you used it on the GUI, you could see like this rainbow effect around the text. I would say in practicality, Bram's absolutely right. I don't know if it's a Gen 2 thing or it's just the manufacturers have figured out a way to do it. At one point, Bram had brought up a PowerPoint or keynote presentation on this display to kind of give us the lowdown on the technology, and I was looking for that very thing, like kind of that fringing around it, and I did not notice. I mean, I didn't put my nose on the monitor, but did not notice it like I did on that first gen.
Yeah, and I would say there's no correct subpixel arrangement besides if you could put them all in the same place magically, which you can't, right? It's just what people are used to. For a long time, people were used to Trinitrons with 2 wires going down them, because of the arrangement of the internals of the display. I don't think that's going to be, especially for reference applications and picture applications, I don't think it's an issue at all.
Okay, so basically, if you can see it, you're way too close. Let's face it.
Yeah.
That's
fine
my
detail. We
feedback
were not
like,
seeing ringing moire or anything like that. And
Okay,
we did play
let's-
with different grain textures on some footage, stuff like that. All of that detail came out perfectly. It's not like there was any artifacting as a result of the subpixel structure.
Okay, we're kind of getting close to the hour, so I wanted to talk about price because you have managed to get the true reference display down in price from where it's been over the last few years, which is a very welcome on its own. What about trying to get it into on-set visual effects houses, all that sort of thing? Now, I know that the size is one of those issues, but will we see something more along, the pricing of a consumer television that we can have as a matching display, do you think? How do you think the price point is going to play out in the future?
So certainly doing them smaller will help us to make them less expensive. A large part of the cost is literally just the freight cost of getting these things around and just the cost of making larger chassis. So if we do smaller ones, they'll certainly be less expensive. I think you can definitely get the pricing down. Now, there are things that we do that cost a lot more money than consumer versions, right? So the all aluminum chassis, the additional heat sinks that we put in, the chips that we use, deserializing chips for 12G, the FPGAs we use, those things, because they're generally made in much smaller scale, and because we're not just using a plastic chassis, which, by the way, tends to trap all that heat and degrade the performance. We're using this metal chassis that actually conducts, the heat away, so it performs better. Those things cost real money, and that's one of the reasons that these tend to be more expensive. But a lot of it is also just the back-end electronics costing more. So I think if panel prices come down, then we can reduce costs. But they're always going to be more expensive than TVs, of course. I mean, this is a very, very niche market. So,
yeah.
But I do think there's room for pricing to come down even more. But again, I will remind everybody, if 5 years ago we had said, hey, we'll get you a 55-inch HDR monitor, this RGB additive, doesn't have volumetric collapse, and it can get to 2,000 nits, and it's going to cost less than 20 grand. Most people have been really stoked about that. And even to this day, you're seeing these, there's still this prevalence of $1,000 an inch as like this idea or concept of what HDR monitors should cost. We're already cutting into that significantly with this product. This is not a $50,000 monitor, it's a $20,000 monitor. So I think things are moving in the right direction in that respect. And one of the huge things that's going to be helpful, and that's already facilitated this, is again, this huge consumer analog of having this large market to sell the same type of panel technology to, means that we're not, stuck paying these huge prices for panels, which is then inflating the end user price into that $1,000 an inch reference or territory for reference displays.
Sure. Yeah, I didn't mean to compare it with the cost of a television. What I was really thinking of was the capital expense. I know a lot of people have been holding off saying, well, I really don't want to, having seen what's happened in the past with the X300, HX310, et cetera, et cetera.
100%, yeah.
I do not want to put probably the most expensive item in my grading suite. I don't want to be investing in that knowing that it's going to be obsolete in a year or 2 years' time.
I think this will serve very well. I mean, one of the nice things too, again, is that because you don't have these things tend to last a lot longer than previous generations of OLEDs. So this is something that will serve people for many, many years. And I think at $20,000, most of the facilities, if you're actually getting HDR work, that's something that as an expense is not, it's not insane, right? And it is actually costing less than the actual, big control services anyway. Sure. So, but yeah, I think things are moving in the right direction. I mean, we have long been that company that has tried to make things more affordable when and where we can. We did that back with 24-inch monitors. When everybody was selling them at 10, we were selling them at 8. When everybody was selling them at 8, we were trying to sell them at 5. So we do that to the degree that we can, and I do think there's room for improvement over the years.
Yeah, and I just add one more thing to that, just that planning functionality, because it's something I think about a lot, right? In running my own business, like where am I going to invest? How am I going to invest? One of the really appealing things of this is that we've been in this alphabet soup of technology, even in the same room for the longest time, right? Mm-hmm. So like, you got, client monitor is one thing, the reference monitor is another thing. We've dealt with all the metameric, problems with that, and the calibration challenges with that. It's really appealing to me to where we're seemingly moving to a place where everything in the room can be the same technology. Is actually really, really appealing, right? And more so that like even in a larger facility that we can have, the same technology room to room, because it's not like, oh, we had to spend, 50 or 60 grand. It's just in this one room. Now we can have that same thing across multiple rooms. And so from a translation kind of thing of, as you said, workflows from VFX and motion graphics or whatever, into final grading and finishing, I think that's going to be a big thing for those who are planning out and, swapping out monitors and facilities too.
Yeah, the only thing I would say about cost is, one, it's really important to remember that even at $20,000, this is half the cost, more than half or less than half the cost of what top level HDR reference monitoring of much smaller size in the past has historically been. So the cost is already coming dramatically down. Also, it's kind of hard to get your head around the size versus pricing a little bit, because we've historically always, that 31-inch size reference monitor is the really big expensive one, and then maybe we'll get a consumer TV for a client monitor. So to see the 55 as the top level reference does require you to kind of think differently about the pricing, right? You're not buying a souped up WOLED that you're going to try to trick into working good enough to be a client monitor, right? It's a reference quality, full performance HDR display that happens to be 55 inches. So I think the price point for that is honestly pretty revolutionary if you look at the cost of that level of HDR monitoring with more compromises over the past 5 years.
Yeah, and I do think that people will, I think that people are going to put a lot of thought into getting rid of monitors in the room rather than adding more monitors into the room. And I think that I see it, the biggest limiting factor of using this display at 55 inches in a room is simply the size of your room and layout of the room, right? The demo suite, at FSI that we were working on was a great example of a room that it really worked well in as a single monitor, right? Because the room was probably 10 by 12, somewhere in that range. There was seating behind the operator area, right? So, it was big enough for somebody sitting behind. I think if you're in a huge room, yeah, you might still need 2 displays and you might need to, wiggle things around. But in a normal average size room, I think with a little bit of rejiggering of your layout, I think it definitely is going to work. Definitely is going to work as a single display for a lot of people, whether that's right on the desk as we discussed earlier, or a little bit ways. But yeah, I think it's going to be good. I'm really excited. I mean, like I get jazzed about a lot of things, and people who know me that like every piece of technology comes out, I'm like, oh, I'm going to get that. And to my detriment sometimes, but I will say I went into this one with like a real kind of hesitancy because I've spent, I mean, I'll be honest with you, I not all that long ago spent, I don't know what it was at the time, 35 or 40 grand on the 310s, you know, and I was thinking, oh, that's my monitor for the next 10 years. I did not expect, and this is an honest assessment, not just because we're here with Bram and he wants to hear it this way. I did not expect to be that impressed by that monitor. I was expect to be like, oh yeah, that's cool, new technology, but that happens all the time. I looked at it and was just like, and the biggest thing, Kevin, I don't, you have to again see it in person. This reflectance thing has been boggling my mind all week. There's something, you know how like in the days of 3D, like people talked about negative and positive, you know, parallax and kind of that 3D effect. There really is something, I can't put my finger on what it is, but three-dimensional about the way that this display looks that I wasn't planning on, and like instantly like brought me into it. And I was like, oh, I want to look at this more. So it's weird. I encourage, like, go to those trade shows, get a look at it, or go down to Atlanta, because I think a lot of people are going to be like me.
Yeah, the lack of reflectance is apparent even when it's completely turned off, just because of the material it's made out of.
Yeah, it's very cool.
So let me put you on the line then. Let's say you bought a reference monitor, a full-on HDR reference monitor, 18 months, 2 years ago. So you paid out your $35,000. Would you replace it with Quantum Dot today? Would you say I've had my value out of that, or would you let it run a little bit longer and say that my next thing will be Quantum Dot?
Well, I think if you always say the next thing, you're going to be constantly waiting, right? I mean, the same thing's
absolutely
true with computers or whatever. It's a great question because it's actually a very similar situation to what I'm in. And I think the thing to understand is it doesn't make that 2-year-old display, the phallic in our case, it doesn't make it obsolete, right? Like there's still very much good reason to have a 3000 nit monitor that's a phallic display, because, you know, translation about, you know, not everybody's going to be viewing on QD-OLEDs and stuff. But I would say, honestly, if I was doing it from scratch, setting up a new room, no, it's a no-brainer. Yes, don't just invest in it, do it. I think it's the way forward. For those who bought, you know, HX 310s or FSI monitors or whatever in the past couple of years, I think that's going to be a case-by-case thing. But I would what I would say is I would urge people to look at it to make that assessment, because I think once you look at it, it's pretty darn compelling for what it is. And I think that's going to be a hard decision for make. I know I'm already planning on writing that check after seeing it. And I got it. This is honest to God truth. I went into this demo, you know, on Monday going, screw it. I'm just, you know, this is cool. I'll check it out from technology purpose. And I'm not going to buy one. I already spent all this money, and I walked away going, damn it, I got to give Bram.
Yeah, now we're trying to figure out where to fit it.
Yeah, exactly.
Well,
I'll say this in terms of like decision making. If you're building a suite or a facility right now, it's a no-brainer, even if you're not doing a lot of HDR work, because it's still going to be an excellent SDR reference monitor at a great big size where you can be a single monitor room if you want, and then it gives you the headroom to expand into HDR later. If 90% of your work is HDR and you're working on an HDR reference monitor that has some of the compromises or limitations that we've mentioned that this solves, and you don't like that, absolutely upgrade to it. If you're only doing a little bit of HDR work and most of it's still SDR and you have a good monitoring solution for that, maybe wait. But
yeah,
you know, every situation is different. But
I think a lot of people
are really good.
I think a lot of people are also going to be weighing, besides the reference monitor, they're going to be weighing this thing. Well, hey, LG's still doing its thing with WRGB OLEDs, and those are getting brighter and whatever. And it's something that we haven't talked about, but I think is really worth noting. And if you do see Bram at a trade show, he can show this to you, and he figured out a great way to demonstrate this in a PowerPoint presentation. You know, the complaint about WRGB OLEDs and the four sub-pixel structure has always been, because of that white subpixel, you have kind of fold over at high luminance values, right? You start getting color volume collapse. That's really, really noticeable on this display, where you don't get that effect, right? That you're pushing things to max peak of that display, and guess what? It's still green, or it's still pink, or whatever, and it's not dimming down to get there. And it's a really, like, from a colorist point of view, it's actually kind of weird, because I think we've been so used to that kind of natural desaturation, effect as you get brighter, that to see that hold as you get up to 2000 nits, it's like, am I like in the wrong control? Like, you're looking like, what am I doing wrong here? Why is that doing it? And it's really tangible and really obvious on that display.
Well, it's so baked into Rec 709, because that's how Rec 709 works, that a lot of colorists struggle. That's the biggest part of getting into HDR grading, is struggling with that concept. So if you're on a white OLED, that really confuses the brain. So I hear you.
Yeah,
listen,
and
last point, guys, because we're running out of time here. But last point, how about putting different technologies side by side? I know we always dissuade people from doing that, but if you had an OLED and an LCD, not a dual layer, but a regular LCD, good quality one, and a quantum dot OLED side by side. Bram mentioned earlier that they're not doing white offset, so no Judd offset or anything like that. How would they sit together? Would they match reasonably well?
Yeah, so I mean, obviously it's going to depend on what type of backlight the LCD is using, and there's a wide variety of backlight technologies and also front plane technologies, whether it's IPS or PVA or whatever it is. What I will say is that we've compared it with a lot of PFS phosphor, and that's what you find in a lot of Apple devices. It's what you find in the 310K. It's what you find in the HX310. It's what's in the 311K. Those are all variations of PFS phosphor, and it matches that really well. So I think that does pair well. So if someone were to use this in combination with one of those technologies, I don't think they would have many complaints. I think it's a closer match than, for example, trying to pair a WOLED with them. And it's also a much closer match than back in the day when we were dealing with the 24.5-inch RGB OLEDs and all these other large format OLEDs. So matching, I think, is quite good. Again, that comes down to the spectral distribution of the display, and I think it's a suitable match for most of those technologies. So I think that will work well, and I wouldn't really have any reservations about telling people you can use that. Obviously, using the same display technology is great if you can in a room. The single monitor concept is another way to kind of alleviate this idea that you would even need to try to match different displays. So that's kind of where we are on those. And similarly too, like if you're looking at buying like I think one of the things we see with WOLEDs, a lot of people use consumer TVs and as client monitors, and they cycle through them every year or two because they just don't last very long. Instead of dropping, $3, $4, $5 on a new consumer client monitor, this may be something people want to think about. Hey, maybe I'll use it as a client monitor for now. Think about switching my room later. That might be a better investment than throwing a few $1,000s away every few years. So
not to mention the usability aspect of having true SDI versus other consumer connections, not to mention the menu and software ability. And I think one thing that I think as an end user is very, very awesome, especially at this size, because they're much harder to ship around. Now, I'm lucky I have my own calibration gear and I do all that work myself. But if you're a user who hasn't invested that, FSI has always been, hey, send the monitor back to us. Well, that's a much harder proposition when you have a 55 or 65-inch monitor. Now these monitors also have their AutoCal technology. So if you have a supported probe, just plug it in via USB and you're in 15-20 minutes, it runs the routine and you're ready to go. I think for a lot of people, that's going to be a real confidence booster too, knowing that really at any time with a suitable probe, they can run their own calibration. It's going to do all the supported gamuts and EOTFs and stuff like that and be spot on. That's a huge confidence thing.
Yeah, I agree. The AutoCal is awesome. Okay, it's about all we've got time for, I'm afraid, guys, but that was fascinating. I'm absolutely stoked and looking forward to seeing one at least, and getting one soon, hopefully. Thanks everybody for watching. Thanks for those that are tuning in afterwards, after the fact. I know we get a lot of people coming back to see this. Remember, Color Space Cadets will be back at a similar time next month. And also remember that we have live colorist mixers arranged for both IBC and Camera Image this year. So hope to see you all soon. Thanks so much, guys. Great talk. Appreciate it.